Okay, well, hello. Thank you to have me here. I'm glad that Threefold and OpenNebula basically found each other, as I think there is a really good fit in what we can bring together. Now, who are we? Well, Threefold Tech is a Belgian company that has created, to our knowledge, the world's first truly autonomous, decentralized, federated cloud technology for cloud in all these dimensions of storage, compute, network, etc. You could say that we have developed the technology that is equivalent to what solar panels mean to the energy sector. There, next to big power plants, solar panels are able to generate energy on a small scale. Well, in the IT industry, 3 nodes are cloud capacity infrastructure that can run very locally in any form factor, any size, and without the need to have system operators around. Now, we already have proven our technology, as we already have developed our decentralized model, and it's up and running in a grid available in more than 70 countries and with more than 3,000 independent cloud providers, which we call farmers. Okay, so the technology is basically a combination of 3 elements. First of all, there's an open source Linux-based federated operating system. I'll explain a bit in more detail what that exactly means. Then there's extensive automation so that no human intervention is needed anymore to maintain the system. And a third element is a blockchain component bringing trust, which is needed in an automated system and a decentralized system. Now, the first and most essential component of our technology is an operating system. An operating system, to our opinion, is the right way to achieve real decentralization with a guaranteed security and privacy respecting, as only at a level which is very close to the hardware, where you have best control to make storage, compute, and network interact in a secure, fast, and privacy-enabling way. You can make sure that it becomes endlessly scalable without holes in the system. Now, we have developed that operating system. We call it Zero OS. It has a Linux kernel inside, so it's compatible for running any Linux workload on it, like Docker containers, like Kubernetes clusters, all types of storage, any application basically. But the Linux kernel in itself has no features for federation. And this is why all around the kernel has been rebuilt in order to make it federate, multi-user, secure, privacy enabling. First of all, multi-user, it's important. And how do we do this? Access to this operating system, both as a user, as a consumer, and as a provider. It happens through a public-private key pair, the same key pair that is used also to secure blockchain identities, basically. So it's really decentralized, no longer requiring usernames, passwords, which are basically the source of many hacks. So meaning every user can be human, could also be an IT device, has its own identity represented by his own private keys. And they're interacting directly on operating system level. So the operating system has a Linux kernel inside, but all around has been rebuilt from scratch, basically, to enable full security and privacy enabling by design. There are 4 elements basically to make that happen. The first one is persistent storage, where data can be dispersed intelligently over different hardware storage devices, over different hard drives, which could be owned by different cloud providers, by different farmers, in a way that hacking into one hard drive becomes useless, as the data basically is incomplete and moreover it's encrypted. It's why we call it quantum safe, because with incomplete data, even a quantum computer cannot reveal original information, as it's missing information to do that. Second thing is that we got rid of hacking surface of this operating system, as it runs only in memory. There's no shell, and it completely separates the capacity providing side from the usage and the data running on it, meaning that a cloud provider has no insight whatsoever on the workload and the data running on its infrastructure, which is essential, we believe, to have privacy implemented by design. So the user running applications has He has no one looking over his shoulder, even not the cloud provider, has no access to his applications. Third element is a network, which is by design end-to-end encrypted with strong authentication features to connect. And this network can securely interconnect any two hardware devices over IPv6 and with a secure protocol. Okay, and then a fourth element that had to be worked on addresses both scalability and interoperability. It's a so-called smart contract for IT, and it's about full automation of the deployment process of an application. This includes also self-healing. So if a hardware node goes down, then other hardware can basically take over. Okay. The combination of all that brings many benefits. First of all, as we're talking about an operating system, you're able to combine existing hardware components seamlessly, storage, compute, network, in a very secure way. You don't need any fancy hardware to achieve full security. Standard hardware on the market in terms of CPU, internal storage like HDD, SSD, memory are basically sufficient. The security aspect is embedded in the operating system. As the operating system is Linux-based, it allows to run any Linux workload, like containers, like Kubernetes clusters. We have K3s also implemented that is running inside the OS. Storage solutions are possible, etc. Decentralization often blocks scalability. You see the blockchain scene struggle with this heavily. Not in our case, as millions of nodes can be connected and we don't see any impediment to get there. Reliability is another element. It's embedded basically in the features to achieve redundancy with very small overhead. We have mainly in storage, we have a few examples of that on how this works. And then we have, of course, security and privacy by design. We discussed that one. Our model is open source, essentially nowadays, to really push forward progress in maturing the technology. It stimulates collaboration, open source, and it also allows to allocate in a more efficient way the scarce skills that are available on the market. Knowledgeable people, it's hard to find. So we believe that open source is the way to get there. Important for OpenNebula also, I believe, is that the technology can run both on small and big devices, making it available for the edge and also feasible to implement anywhere, given the very light energy requirements, unlike the hyperscale data centers, which often are put next to a power plant to give it a power supply. We have an incentive embedded also through a token economy, which is useful for edge cloud providers to get their fair share of the ecosystem, so that it brings revenue also to these cloud providers. The technology can be set up with a very limited cost using standard hardware and in a small scale. Also there, compared to a high hyperscaler, investment is pretty small. And we're working on making the technology available also on ARM infrastructure, so it can run on even more devices and at the edge. Here you see a nice summary and a comparison with the centralized cloud, which has reached its limits in scalability. I'll share the slide deck so you can have a look at your convenience, but some news now. We are happy to see that OpenNebula is interested in adding the Threefold grid to the provider catalog, and through this offer a real edge cloud to its offering. Really happy with that. And then there's more. We're basically in the final stage to agree on a more intense collaboration around the ONEedge features. I must say, Alberto and I have seen each other regularly during events around cloud at the edge. And both organizations promoting open source technology as the way forward. And after both seeing the needs of the industry to bring what we basically have on the shelf, a closer collaboration appeared to be really evident. So we thank OpenNebula, by the way, for having invited us to join as an indirect participant for the IPK-SIS on the OSMO macro project. That is one collaboration. We are also busy with Gaia-X to explain that we basically have developed a technology for a cloud federation, which is a role that is pretty essential to make the Gaia-X architecture viable. But apart from us, we haven't seen mature solutions yet on the market that really encompass also a commercial model, a governance model, etc. We'd like to have OpenNebula also as a partner within Gaia-X. And we also have plans to participate together in a few calls that will be released by European Commission for Horizon Europe, and also with the Digital Europe program. And we have started our journey already with the Sovereign Edge EU initiative. This one did not get the EU funding that we hoped for, but I'm sure that this initiative will find its way to realization anyway, as we have a very strong consortium and proposal there. So yes, I'm pretty excited to start the journey together. You can find a lot more in our wiki, which is here on library threefold.me. And I'm of course available to discuss anything that you need to know around our technology and collaboration. And thank you.